We would like to apologize for the cut in the YouTube feed. We are back on air now with Mr. Alan Peed. We are now answering questions. Currently, we have 2 questions from Mohammed. His question is, what are the IAD or software tools, also the add-on plugins, utilities to download in order to install in the operating system?
To get Maui to work. So
Yes.
all you need, if you're on Windows 2022, and Maui will be there as a workload. So everything will be installed as part of the Visual Studio 2022 installer. So you don't have to install anything else. You had to when it was in preview, but right now it's part of the Visual Studio 2022 workload. If you're on a Mac, you can use Visual Studio for the Mac as well. It's available in 17.4 as part of the installer.
Thank you. His second question is, can you explain the project tree repository field and the role function for each one?
That it broke up a little bit.
Sorry. He asked if you could explain the project tree repository field and the role and function for each one.
The Solution Explorer, I'm assuming
Yes.
that question is. Yeah, so in Visual Studio, you have a top node, which is the solution. So a solution can be many projects, and which the projects generally translate into a shared library or a full application. So the solution there will be basically holding maybe your Maui application and maybe your ASP.NET application as well, and then shared libraries between those. If you've got an IoT project, it could be part of that solution as well. So that the tree will start solution and then many projects. And then Maui itself will be a single project. That's a difference from Xamarin and Xamarin Forms. Xamarin used to be many projects per platform, but Maui is now a single project. And then the tree under that will be shared stuff, unless it's in a platforms folder, which then will be native for those platforms. So either Android, iOS, or Tizen, or whatever those platforms are.
Right. Thank you. It doesn't seem like we have any other questions at the moment, so we'll give them another minute.
Assume we're going to be sharing these slides.
Yes, thank you. We'll have to share those. We can leave it in the YouTube video underneath the description. We'll list the links there.
Okay, awesome. Yeah, because it's this last page here, because last slide has many good getting started links.
Oh yeah, I saw those ones, as well as your socials and those various groups you said that people can join and learn from.
Yes.
Right. It doesn't seem like we'll be having any more questions. Thank you for joining, Alan. It was a very informative presentation, and I enjoyed it quite a bit.
Okay, cool. No, thank you for having me. I'll see you just now again for IoT.
Yes, we'll see you for the second part.
No, cool.
All right. Coming up next, we will have Dr. Mchali. Dr. Mchali has taught at the Webster University in Columbia, South Carolina, in the USA for over 10 years. He held the position of a deputy chair and assistant dean of curriculum for the School of Information Technology. Before he became the chief information officer appointment, Dr. Mchali was the head of the Department for Information Technology at the Durban University of Technology. He was also the acting director of information technology in this Information Technology Support Services. He will now present Programming IoT Wearable Devices. Thank you, and please welcome Dr. Mchali.
Thanks, Golem. Can you confirm if you can hear me? Okay. It's just that since I'm presenting, I'm only seeing the PowerPoint presentation. Well, this afternoon, good afternoon, everyone. Again, thanks for inviting me to be part of this exciting conference. Earlier this morning, I did indicate that This conference has been running for several years now. And the goal is that someday it'll be a very big conference where if it would even have to could reach, I guess, people worldwide. Again, my name is Progress Mjali. I'm the Chief Information Officer at DUT. Long story short, I was in software development for many years. Actually, more than 3 decades. I started as a programmer, I ended up being a research architect. So I used to have a passion for writing code, but in my role, I don't get enough time to actually do all of these things that we can do with a computer and programming. Maybe interest in operating systems, to writing device drivers, to application code. So I still look at what's actually happening in the field, but what I still do research and publish some papers. But my latest interest has been around wearable devices. Maybe there's a bit of a background. Because one of the things that I tend to look at is, can we use maybe IT to solve practical problems, especially in our country, given a lot of these challenges that we face, especially around the healthcare system. It's very painful if you visit the hospital and you see long queues, and maybe even the hospital has one X-ray machine or doesn't have any at all. The thing is, my wife is a medical doctor, so we tend to talk about some of these challenges around the healthcare. So I started to look at some of these wearable technologies to see perhaps if they could alleviate some of the problems that we actually have. So what I'm going to do is just do a high-level view. I know Alan was writing code and all of these things that I used to do with the Visual Studio, going way back before there was even a Visual Studio, because we used to write code from an editor that had nothing in it. You had to write every line of code and then save it, get out, go to the command line, run CL or CS to compile the program, run it. I guess the modern tools have made that work a lot easier. And even in terms of productivity, we can build applications much quicker. So I wanted to focus at least, maybe see if I can get more developers, especially some of our students that are coming up, to take a look at this, I guess, interesting area, maybe around coming up with solutions that can even help our hospital systems. So I'm just going to mainly talk about what we monitor in healthcare, because this is where these wearable devices are used mostly, but it can actually extend outside of the healthcare. But where I guess it might have a biggest impact would be around the healthcare. And then couple that with IoT. I know Alan is going to touch on .NET IoT, which is exciting as well, because I've played around with the Raspberry Pi and maybe writing a little bit of code to do different things, a variety of things with it, and that's very interesting as well. But then couple that with the wearable, of course, sometimes they call them wearables or wearable technology. And then just briefly touch, Alan did also touch on Tizen as the operating system. And it's not the only one. I think given our environment at DUT, a lot of times we tend to focus more on the Microsoft platform around .NET and I guess C#. So if we look at some of the things that we do, because measuring the pulse rate is one of the things that's actually important, because if your pulse rate goes very high and you don't have a way of actually measuring it, it might end up being catastrophic because there could be something going wrong. So that these wearable devices are helpful in terms of maybe measuring this. I guess to sensor what your rate pulse rate is. The other one that's very interesting, recently I'll maybe talk a little bit about some of the devices that have recently come on the market. One of them, for example, I wear the Galaxy Watch, I guess version 4. The problem with it just eats too much battery. It's one of these things that I guess it actually measures. Maybe it could be the 5, but I'll touch a little bit on that as I move on. So that is important to monitor because temperature. The wearables are very good at doing that. Maybe we will have more and more of them that are going to come out, and then they get refined to where maybe even they become more and more accurate. The other one would be the oxygen levels. That's also important. Maybe if you go to a hospital, I've seen some of the devices. There's one that you can just wear on your finger. I think I have one of those that you can maybe measure 3 different things. That's another thing that's actually important. What these devices actually measure. And then, of course, blood pressure is very critical. The Apple Watch, it does have, I guess, the ability to tell you what your blood pressure is. A lot of times, we might question as to how accurate, I guess, this is. Maybe accuracy, I don't have any maybe research studies that have quantified as to how accurate these are, but at least it can give you a general idea as to whether your blood pressure is high or low. But then you can use other conventional, I guess, means like wearing a blood pressure cuff, and then use the old method of pumping, I guess, air, tighten it, and then you have to be trained as a nurse or a doctor to do that. But there's another method that's a little bit, I guess, established. But the wearable devices, as far as measuring blood pressure, I guess the accuracy is going to get better, I guess, over time. So the other one is glucose tracking. This one is also critical for people who are diabetic, because a lot of times people they reach a stage where maybe the situation is critical because somebody was not measuring their glucose levels. It's the old method. Used to be have to, I guess, prick your finger, take a sample, and then put it in the machine, and it would tell you. But what's even better is that if you have a device that's continuously monitoring your levels, as soon as it notices a spike, maybe it might notify you that there's a problem. Again, this is a better method than what was done before. Because a lot of times when people even end up in a coma, it might be because they have not been checking their blood sugar, especially after maybe eating something that's likely to raise the glucose level. The other one is the strokes, I guess, sensing. I've seen maybe 4 or 5 cases already where an Apple Watch saved somebody's life. Is very, I mean, it's a very good story. One of them was this gentleman was wearing the Apple Watch. The watch kept, I guess, notifying them that he was having AFib. And then he kept ignoring it. And then the notification kept popping up again and again. And then he was getting annoyed. Then he asked his wife if she could wear the watch and see if it does the same thing, because he was thinking that maybe it's faulty. So when his wife wore the watch, it didn't display any notifications. So he took it back and put on his wrist, and then it came back again, notifying that he was having AFib. Then his wife said, "Now let's go to the hospital and actually check this thing out." So they went to the hospital, and then they used conventional methods to actually check. And the result was that, yes, indeed, he was actually having AFib. So he was able to actually receive treatment. So that, I guess, one of the examples in terms of this wearable Apple Watch saving somebody's, I guess, life. The other one would be, I guess, asthma. monitoring, because this can actually become a problem if it's not monitored, because sometimes the air quality may not be as great. It may lead to somebody experiencing these problems with it. So the other one is a sleep monitor. I remember many years ago, I was using the Fitbit when it came out, where it could use that sensor to track your sleep. And then in the morning, you could actually look at your watch, not your watch, your phone, for a report on your sleeping patterns. What was interesting was that I go to sleep, I wake up in the morning, and then I would feel like I slept throughout the night. But if you look at the report, there were cases where I would actually be awake, but I couldn't remember when I was, I guess, asleep. The short of this is that sleep apnea is a problem for some people, so that they have to monitor, I guess, their breathing patterns, because when you have sleep apnea, sometimes you stop breathing for a period of time, and then it can actually become a problem, because that means if you're not breathing, you're cutting off that oxygen supply. And then the heart attacks, again, that's very related to the OS. So, okay. So those are some of the areas. It's just some of them, but the list keeps expanding as more and more sensors get developed. But if you look again, if I start from I'm just checking the time. Okay. So if you look at IoT, we are referring to the collection of network devices and technology that facilitates communication between these devices, sometimes actually using the cloud, which is one of the preferred methods, because then it means that it doesn't matter what, in terms of your location, you could actually maybe gather some of this information and then maybe send it to the cloud for processing. So in this graphic, as you can see, you do have wearables that are actually tied to IoT, because a wearable is not going to be good enough if I'm wearing it now. It collects the data, but there's no action that takes place from the data that are collected. Whereas if you use the Internet of Things, maybe there's a cloud, or maybe talking to a phone, then there's an action that can be taken based on the notification that was just posted. So the other one you can see, again, these are the wearables. These are the electronic devices that I was actually talking about. We'll go through a few of these examples, and then in the end, I'll close by looking at how do we then build applications that can actually be used maybe to solve some of these problems that we actually have. Remember, again, I was saying that in our country, we have a lot of challenges where perhaps we can start to build applications that can alleviate the healthcare system problems that we actually have. So if you look at this example, again, these are not new pictures. They started like the Fitbit. I'm not saying they were the first one, but we got introduced these wearables through the Fitbit, and right now, you have the Apple Watch. Again, is one of the most popular, and then the Galaxy, and then Samsung Galaxy. It does also have these sensors that are able to maybe get you an EKG, which is one of the things that I'm interested in. I do wear one where I'm monitoring, I guess, my EKGs. And then Huawei, they are coming up with ones, and then Google. So that space, there's also Garmin. They have a good one. So there's quite a number of devices, wearable devices in terms of the watch, maybe form factor, that are coming on the market. So there might be an interesting data thing that I had was, how do I even write code? How do I build an app? Because like when you use Visual Studio to build desktop apps, that's pretty straightforward. And then once you started doing mobile devices for the phone, Alan was talking about .NET MAUI. So we were focusing on that. My thinking is that we should also focus on building the apps that actually run on these wearables. And then a few of them, this is the Oura Ring, which can actually sense some of these things from your temperature, for example, your pulse rate, because you just wear it as a ring. In fact, there is a group of students Lava Lock, I think that's the name of the company, that was using a ring similar to this at DOT. They were, when I was the HOD at the time, they were piloting it in terms of using the ring to access the labs instead of actually using cards. But again, it's got all of these sensors. You can look at your pulse rate. You can look at maybe some of them may have the ability to look to measure your blood pressure. So there's a proliferation of them is coming on the market. This one is also interesting, even though it's not a wearable, but it does maybe monitor your sleeping patterns. The Amazon Halo Rise, because it monitors your temperature as you're sleeping, your breathing, I guess, patterns and other features to actually then give you a report as to how your sleep was the night before. And then this is there's a research one that's upper right hand corner that is actually used as some kind of a fabric. What it does, it senses your electrolytes contents just based on your sweat. And then it could look at also try to measure maybe how much salt intake that you have based on I guess the sweat that is coming in out of your skin, and that information can actually be relayed to I guess your phone. So this is an experimental one. I think I forget the name of it. Could have been Stanford University. I believe I'm correct, where they are developing this one for being able to measure tumors under the skin. So it will just be weighted on top of the skin, but underneath you would be able to tell you the size of a tumor if there is one underneath. And then this interesting one, I misspelled glucose. I apologize for that. For monitoring the blood sugar, as I indicated before, the old method used to be you have to prick your finger, take a sample, then put it in a machine, then it'll give you a reading. That sometimes you may not have time to go through all of it, but this newer technology, it actually is attached to your skin, or you weigh it on your skin, and is continuously monitoring I guess your glucose levels. And then if there's a spike, you might actually send a notification to your phone so that you can actually take an action. This one is also an interesting one. It has a heat sensor. An example that I saw was used in Dubai in some of the mines, because the temperatures in the Middle East, they can be very hot. They can go up as far, I mean, as high as 58 degrees, so that it becomes dangerous for people to continue working when their temperature or they has gone way up. So this Kenzen sensor does it will measure how hot it is in the area, and if a person is in a danger zone, then it might notify them that they actually need to go out. And also the company can monitor everybody, maybe using a dashboard in a control room. If it's a dangerous situation, then I guess ask them to actually get out of their environment. This one is also interesting. It's used in the NBA, which has all of these different sensors in order to prevent injury, because it looks at your muscle structure. Because basketball players, they do a lot of movement. They be jumping and they be running. Maybe they might start to develop some problems maybe before they even get a cramp. It looks at a number of different things, but it actually is one, as you see it on the left, and there's a little device that actually communicates with it to capture that information. Again, this is just some of the sensors. There are a lot more that we see, I guess, out there being developed. So if we look at the healthcare side of this, we look at all of the different things that we monitor, and then all of these devices that are able to do that. And then we said if they are connected via, I guess, IoT, that information could actually be fed into the healthcare system. For example, if you think about these as hospitals, you send somebody to a hospital and there's a queue. Maybe they don't have enough machines to take a pulse. For example, you can ask them maybe to wear just this watch that can collect all of that information, and then that information becomes available to the healthcare workers. Because if you remember, if you've ever been to a hospital or doctor's office, the first thing that they do is take your vital signs, where they will take your pulse and take your temperature and then measure your height and all of those kind of things. But if you can use these wearable devices, somebody walks in, maybe they wear these things, captures the information, automatically upload them to a healthcare system, so that actually might cut down on the time that is necessary to actually treat each patient. Again, this is what would happen if we go to the healthcare. Now, the other thing in here, you look at the phones, so I'm including this as part of the IoT, because if I'm wearing, let's say, an Apple Watch, and then I have a phone, so there's communication between the two. Because like I said, the sensor itself is not good if the data that it collects cannot be actioned. But if it gets transmitted to the phone, then it can actually be actioned, because you could be set it up so that it can actually be sent to a system that actually runs in the cloud. So I'm just using this picture as a phone that from the device, the information goes to the phone. I'm running out of time. And then in terms of healthcare, then we look at these three systems: the wearables, the phones, and then the healthcare. The wearable is going to be using the sensors to get whatever information you want to collect. Then you can use your phone as a conduit, because you have your phone in your pocket. And then your phone can actually send you notifications already that's sort of localized. But if the application can be built in terms of it notifying somebody or notifying your doctor, or however that could be, configured so that an action is taken. So what I'm saying in here, yes, let's say it's an Apple Watch, and then the information gets collected from your arm, and then it gets sent to the device, to the phone. The phone then can maybe have an application that can take action, like notify somebody, call an ambulance, or notify, your doctor. So again, I'm just saying the same thing, that from the wearable, information goes to the phone. From the phone, then it could actually go to the healthcare system. A couple of them, I did talk about this EKG. We do have this device that at one point we're looking to do research with it, which is actually not a wearable, but you would touch your fingers on the left node and the right node, and then that information gets transmitted to your phone so that you can see your EKG, being developed. If you see signs that you may be having AFib, then you can take action by going to the hospital. So again, using phone to do that. And then this is the classic Samsung Galaxy. In fact, I remember when I was trying to do research in this area, when I bought one, South Africa was not on the list of the countries supported. So this thing was actually turned off. So that research was going to go to, I was going to put on the shelf until I did an upgrade or a software update, and then it had enabled. Now I can at any time just touch that button up, and then I take just sample for 30 seconds, and I can get